Assalamu alaikum. In this lecture of instruction sets and their characteristics and function, we will start to discuss about machine instruction characteristic. Like the operation of the processor is determined by the instruction. Likely it executes referred to as a machine instruction or a computer instruction. The collection of different instructions that the processor can execute is refers to as a processor instruction sets. So each instruction set may contain the information required by the processor for execution. For this purpose, we see in next example like shown for you, in which you see that the first one is opcode and the second one is address side. So in this example, you see that we load the memory of a location of like 0001, and then this AC to store into the memory, and then add this into AC. This example, you see that the CPU register, which one is a program counter, and IR represents interrupt request. So in step by one, you see that memory location, it will process by process, and then your program will execute, and one by one your location will be changed, and store the data one by one sequentially. So the elements of machine instructions are like opcode, which means that operational code. Opcode, it's specify the operation to be performed. The operation is specified by like a binary coding known as the operation code or opcode. The second one is a source operand, like a reference, which means that the operation may involve one or more source operands. That is like operands that are input for the different operation and tasking. In a result operand reference, the operation may produce a result. So the instruction reference, which tells about the processor where to fetch the next instruction after the execution of the instruction is complete. When one instruction will complete, then it will go into the next instruction, which will be in queue form. In this example, like our instruction cycle state diagram, you see that from left side, instruction fetching, and then our data instruction address calculation, and then it will decode. After decoding, it will operand address calculate, and then it will be fetch the data, and the data will be operated like in execution form. After that, the data of address in calculation, it will be stored in memory, and then at last it will be executed. So the source and result operands can be in different four areas. First one is like main or virtual memory. As from the next instruction reference, the main or virtual memory address must be supplied. The second one is IO devices. The instruction must specify the IO modules and devices for the operations. The third one is like processor register. A processor contains one or more register that may be referenced by the machine instruction. If more than one register exists, each register is assigned like a unique name or a number, and the instruction must contain the number of the desired register. The fourth one is immediating. Like immediate, the value of the operand is contained in a field in the instruction being which the user want to execute it. The next one is like instruction representation, and that the way in which how can we represent the instruction. So within the computer, each instruction is represented by a sequence of bits. In a digital system, in computer system, we play with the bits and bytes. So the instruction is divided into fields like corresponding to the constituent elements of the instruction. Like first one is operation code opcode, which is 4-bit, and the operand reference, which will be 6-bit, and it may also be 6-bit. So its total space is about like 16-bit. We can say that it will be a 16-bit processor. So in next lecture we see and calculate how can we judge about the memory sizing of a processor, like it is 16 bit, 8 bit, 30 bit, 32 bits, or etc. So instruction representation like opcodes are represented by like abbreviation name as mnemonics. So in example you see that add is a mnemonics of addition purpose. Sub is mnemonics which represent subtraction. Mul represent about multiplication. DAV which tell us about division. Division functions. Load means load data from memory. There are too much difference between load and store. Store it's mean that your data store to the memory. It's mean that data are you're in backup position, and load means it means that your data is in form of like processing purpose. So operand are also represented symbolically. Each symbolic opcode has a fixed binary representations. So the programmer specify the location of each symbolic operands. Instructions in this example we consider a high level language instruction, like in example you see that x is equal to x plus y. So we are assuming two variables like x and y, and there are some location in this example we locate the location 513 and 514. So what it means, first load a register with the content of memory location. It's mean that the location of x which in memory it's 513, and the location of y is 514. So when we will add x plus y, so we will go at the location at 513 and 514, then at that location there is some data, then we will add it. So in third step you see that store the content of registers in the memory location of 513. So, any program written in high level language must be translated into machine language for the execution purpose. So, the instructions like set of machine instructions must be sufficient to express any other instruction from high level language to machine language, or machine language to high level language. So, there are different types of instructions like data processing instruction, data storage, data movement, and controlling. The left side first one is arithmetic instructions. So it provides computational capabilities for processing numeric data, like numeric functions, different addition, subtraction, multiplication, division, and anyone more. So logical, like boolean instructions operate on the bits of words as bit rather than our numbers. So they provide a capabilities for processing any other types of data the user must wish to employ. So the movement of data into or out of register and our memory location, it's for type of data storage. Controlling, in controlling section of like a controlling instruction types, the test instruction are used to test the value of a data word or the status of computation. So like a branch instruction are used to branch to a different sets of instruction which will be depend upon the decision like processor or user will be take. Data movement in IO instructions are needed to transfer program data and into memory, and the result of computation back out of the user. In this example you see that like different instruction, first one is a sub, and there is mnemonics and their formats, and the third one is comments. In comment section you see that it tells us like in first one sub y comma a comma b. It's mean that a is subtract from b, then their result will be stored in y. And the other one is you see that multiply, and it's mean that d and a e will be multiplied, then the data will be stored in the t register. These are three address instructions. In two address instructions, there are different types of address instruction, like one address instruction, two address instruction, and three address instruction. It will be important thing that which type of address instruction you will be follow according to your instruction sets, according to your program. If there is some mention in your in any uh, problem or question that mentioned that you solve this program like one address section, two addresses instruction, or three, so you will be remember that like in two addresses instruction you will see that there are some different of like mnemonics and their instructions, and their working, and in one addresses you see that only one addresses will be used and how it will be work. Like example will be given there. So how can you solve it? Like y is equal to a minus b and then divided by c plus d into e. It's a home task. So instruction addresses, how can we accumulate or use save in their accumulation and different purpose of branching instruction or any one more. Instruction set designs are very complex because it affects so many aspects of computer system. It defines many of functions performed by the processor. Programmer means of controlling the processor. So fundamental design issues of different operation range, data types, instruction format, and their registers and their addressing molding. Different types of operands, addresses operands, number operands, logical data, and characters. First one, we will discuss numbers. All machine languages include numeric data, like in the form of zero or ones, which we can say that in the format of binary. The number stored in a computer are limited, so a limit to the magnitude of the number representable on the machine. So in this case of floating point number are limit to their precision, that after points how much number we will calculate for their calculation. So there are three types of numerical data which are commonly used in our computer system or digital system, like binary integer or binary fixed point, binary floating point, and the last one is a decimal point. So how we will use packet decimals. So each decimal digit is represented by a 4-bit code with two digits stored per bytes. 1 bit is equal to 8 bytes, as you know that. So to form the numbers like 4-bit code are strings together, so usually in a multiple of 8 bits. Characters, the sizing of character we will discuss there. A common form of data is like a text, like a character, like a strings, like alphabets. So text type data in character forms cannot be easily stored. So for this purpose, data processing like communication system, they are designed to convert these data into binary form, like binary digits. So you know about ASCII codes, mostly commonly used characters codes in the international reference alphabets like IRA, which are American Standard Code, ASCII codes. We discuss. So another code use encoded characteristic in extended binary decimal interchange code like EBCIDC. EBCID is used in IBM frames like mainframe computers in starting decades. So logical data. N-bit unit consists of n 1-bit items of data. So each item having the value 0 or 1. Two advantages of bit-oriented views, like memory can be used more efficiently or for storing or any array of boolean or binary data. Item in which likely item can take only one values, like either 1 or 0. In other format you say that true or a false value. So to manipulate the bits of data items in example, for example, we need to be able to shift significant bits in some operations, like a shifting of data from left shift, right shift. We will discuss in next lecture. In this table you see that different types of data types and their discussion, like in general types of data, it may be word type like 16 bit, it may be double word like 32 bits. Their data types also represents their size, like how much bits it will be occupied in a memory. Like integer types, it will be signed integer, like double integers, unsigned integers. There are different types of data types, like in bits type, like character types. uh, you see that in this table there are different types of data types, and which type of data you will be use in their programs and their instructions coding. And you want to make a program, for this purpose you will be see, and also you will be analyze for making any processor or any controller, their data types, and there's some matching will be more important for execution purpose, for our log file. You say that for processor efficiency, speed. And another some things, it will be also mentioned in a textbook. You see this when you also go through it. It's The main purpose of this table is when you make some processor or some action you want to perform for practical purpose, you know about these some things which will be important. So data transfer, how? Most fundamental types of machine instruction, it specify location of the source and destination operands. It means that you want to transfer data from source to destination. The length of data maybe transfer must be indicated. So we will also mention that how much type of data we want to transfer. Um, the mode of the addressing for each operand must be specified. So in arithmetic operations, most machine provides a basic arithmetic operations, as you know that addition, multiplication, division, and anyone like squares, under roots, etc. So there are provides for like sign integers, the decimal points, absolute point, negative, increment, decrements. You see in the logical operations, like in digital logic operation, there is some variable p and q, and in logical operation there are some combinations. And the third in third column, you see that not of p means the value of p like 0, it will be 1. And in this one, p and q, like p and q will be perform AND operation, p or q will perform OR operation, then exclusive OR, then this operation. These are logical operation in logical gates. You also study that how it will work and how its to table will use. So another thing is that data, how you want to shift, logical left shift, logical right shift, arithmetic right shift, arithmetic left shift, data rotation, left rotation, right rotation. There are some examples we are quoted that how can you shift 3 bits. You see in the first example, this is input, and we want to logically right shift 3 bits. So you see that only 3 bits will shifting, and the result will be like this type. And you see that in second example, uh, for logical left shift like 3 bits, and yeah, another example, you see that arithmetic left shift, rotate, and many more example you can also see in books. So conversion. So how can we convert like instruction that change the format or operate on the format of data? Conversion means that which type of instruction we are given, like an example of conveying from decimal to binary. You mean that binary system, you also read that and also taught that from one decimal system to one number system to another system. There is some example of complex editing instruction, which will be different varieties of operators, like isolated program IO, memory mapped IO, and these are these important things like DMA, direct memory access. So many implementation provide only a few IO instructions with the specific action specified by parameters, codes, or common words. In system controls, we see that instruction that can be executed only while the processor is in a certain privileged state or is in executing a program in a special privileged area of memory. Typically, these instructions are reserved for the use of operating system. Like example of different operations, you see that a system control instruction may read or alter control a register. How transfer of controls? The reason is that why we want to transfer a control operation are required. The main reason is that it is very necessary things that will be able to execute each instruction more than once, that we want to execute instruction multiple times. For this purpose we use control transfer, like virtually our programs involve some decision making. So it helps if there are mechanism for breaking the task up into smaller pieces that can be work on at one time. So most common transfer of control operations found in instruction set like branch instruction, skip instruction, or procedure call instruction. This example, you see that different types of instructions you can use and apply in those your compiler you are using, and you see that what will it will be result. So skip instructions like you there's some example you can also perform in your compiler, and then you see that you will see that how these instructions will work. Like procedure call instructions, it's like a self-contained computer program that is incorporated into a large program. At any point in the program, the procedure may be invoked or called. Processor is instructed to go and execute the entire procedure and then return to the point from which the call took place. So, two principal reasons for the use of procedure. The first one is economy, and the second one is modularity. So, it involves two basic instructions like call instructions and return instruction. So, you know that what is the purpose of call instructions and what is the purpose of return instruction. It also mentioned there. This is a block examples like how can it work, execution of instruction that one by one, call instructions or return instructions. uh, so in this next lecture, instruction sets are like different type of addressing modes and their formats we are discussing. The first one like addressing mode. The addressing modes are an aspects of instructions set like architecture in which most of different CPU design. It's mean that different which type of addresses like you are use for the making of a processor like a CPU. The various addressing modes are defined. They tell us how the machine language instruction in that architecture identify the operands of each instruction. In last lecture, we discuss about like different operands and instruction like subtraction, multiplication. So addressing modes will guide us that how these instructions will work for, and how they guides to do a processor that which instruction is what their task and how it will be work. So these are important thing, addressing modes. uh, there are different types of addressing mode like immediate addressing mode, direct addressing mode, indirect, register, indirect register, and displacement and stack type. There are all types, and we will discuss in next slide one by one. There is a simple diagram in which we are try to understand. The first one is like immediate addressing, the second one is direct addressing, the third one is indirect addressing, the fourth one is register, and fifth one is like register indirect, and then displacement, and then stack. So in this like block diagram, you easily understand that in like first immediate means that you want to perform a instruction in within second without any hurdle or without any delay of time. So second one, you see that in direct addressing mode, or memory has some instructions, and we will go directly on this operand. And in third one, you understand also that or indirectly means that we will go on another memory location, then we will bypass from this location to another. In other example, you also judge that from this like we also see that in register indirect addressing mode, or instruction will be in at any location of register, or register will go then memory, and then this instruction will be executed. And different types of notation are using like a which means that contents of addresses field in the instructions, are which contents of addressing field in the instruction that refer to a register, ea actual effective addresses of the location containing the reference operand. So x content of the memory location, x or register. So there are different types of addressing modes we are you see in last slides in the blocks form, and their operands and their algorithm, how it will work, and their principle, it's their benefits, their disadvantages mentioned in this slide, which one is more benefit for this for which purpose, and which one is flexible, which one take memories, which one take less memory, which one take no memories, their advantages, and some there is some complexity, and some the main the issues that they're addressing spacing. So immediate addressing, there is example of immediate addressing in which you see that like example, add 5 or the contents to accumulator. So we want to store a operand of number which add 5 in the accumulator. This mode can be used to define and use constants or set initial values available. So the leftmost bits of the operand field is used as a sign bit. So what will its advantages? The first one is the no memory reference other than the instructions fetch is required to obtain the operand. So the saving of memory cycle in the instruction execution. Another is its disadvantages, that the size of memory addressing field in like comparison is too much. So instruction sets will be not more compatible for this purpose. So in direct addressing, you see that examples how you can directly address your instructions in this graphical representation. You see that. So direct addressing is another the next one is direct addressing. In direct addressing, you see that you directly access your address, and their advantages are single memory is used for accessing no additional calculation, and but the disadvantage is that limited address space, and the length of address field is usually less than the word of length. So next one is indirect addressing. The names says that indirectly we will assess the data. So there is the one advantage is that the address space is the in the we can check it by the multiples of 2 power n, and the advantage disadvantage is that execution requires much memory for fetching operation, because you see that you will go to one memory and then go to actual memory, so due to which our memory spacing will be occupied more. You see in this example. Also the next one is register addressing. in which the data will be stored in register, then from register it will move to memories. So there are some advantages and disadvantages are mentioned there. It will be important for this purpose when you use a different type of addressing, so you know that which type of addressing is much more important. Like a register indirect addressing, so our data will be in register, so we will approach indirectly from different addressing sequence. So you see in this diagram displacement addressing, it combines the capabilities of like direct addressing and register indirect addressing. Like in this example, you see that it requires that instructions have two addresses fields, at least one of which it is explicit. So the value contained in one address field like is used directly, and the other address field refers to a register whose contents are added to a, then it perform next task. So their most common using is that in like relative addressing, base register addressing, and for indexing purpose. This example, the block diagram tells us how displacement addressing working. Relative addressing means that your data will be relatively implicitly registered from program counter to memory, and then different next instructions added to the address field, and then it will the main is advantage is that your address bits are size of memory save, and your instruction cycle are like instruction your cycle execution time will be reduced. These are also base addressing register addressing, but it will be only for this purpose, that how can we address the data. The important thing is indexing. The address field reference a memory address, and the reference register contain positive displacement. There are some auto indexing, post indexing, and pre indexing. Stack addressing, stack is a linear array of location. So sometimes referred to as a push down list or list in first out queue. A stack is a reserved block of location. So items are appended to the top of the stack so that the block is partially filled. The stack pointer is maintained in a register, and like example, you see that pop top to two items from stack and then added. So the machine instructions need not include a memory reference, but implicitly operates on the top of the stacking. In this example, you see that how it works. Instruction formats, and you define the layout of the bits and their instructions, different operation codes, and how instruction format is used and it will work. Instruction length, most basic design issues are like memory size, like memory organization, bus like data bus, memory bus, so bus structures and processor complexity, processor speed. There are some main issues which we can overcome by using instruction length. So it should be equal to the memory transfer length, or one should be multiple of other.